Welcome to ID Odder. Today we are going to be going over Layerzero project. What is Layerzero? Layerzero is an omnichain interoperability protocol. Layerzero enables the realization of cross-chain applications with a low-level communication primitive. Layerzero is a trustless protocol that will enable users to send tokens or any kind of message in a single transaction across applications that live on various chains. Unlike traditional bridging, which requires users to lock their assets, or blockchain networks that utilize a single relayer or facilitate transactions between fast finality chains, Layerzero is generalizable enough to run on any chain, across the full spectrum of security and scalability assumptions. So what make Layerzero unique? Firstly, Layerzero processes data through ultra-light node. Currently, blockchain processes data through nodes. The more optimized version of node will be light node with lower cost. Layerzero with information processing technology through ultra-light node will bring high cost effectiveness. Secondly, use cases. Today cross-chain messaging is synonymous with bridging, but there is much more you can do with Layerzero than simply bridging assets. Layerzero enables cross-chain, state sharing, bridging, lending and borrowing, swaps, governance, and much more. Thirdly, its swap capacity. Existing AMMs can be wrapped to perform cross-chain swaps from one asset to another without the need to modify any existing code. Users will be able to swap from ETH on Ethereum to Sol Solana in one single transaction from the source chain. Fourthly, state sharing in Layerzero. SushiSwap exists on 12 different chains with each instance running in a siloed ecosystem. If they want to sync state with their main Ethereum instance, they'll have to write code for using Wormhole, Rainbow Bridge, Polygon Network Bridge, Avalanche Bridge, etc. The end result is 11 sets of code, with 11 unique interfaces and 11 different security properties. Since the ecosystem of bridges and new L1/L2s is constantly in flux, this becomes an unmanageable proposition. When using Layerzero, SushiSwap would have one single interface and code base for all cross-chain pairs. They only need to implement send and receive functions. Send consists of forming a message for the destination chain, and receive simply interprets that message. Fifthly, its security properties. In breaking up responsibilities between the oracle and relayer, Layerzero leverages the security properties of the established oracles, Chainlink and Band, with an additional layer of security via the open relayer system. While this may seem only a small difference at first glance, its implications are quite profound. First, it means that the worst-case security of this new network still reduces to being as secure as the oracle. If you use Chainlink as your oracle, any malicious action in the system is still predicated on first being able to defeat the Chainlink Don, no easy task. Even if the oracle's consensus is corrupted, it also requires that the relayer is actively colluding. For example, in the most extreme case where the oracle A's consensus is corrupted and the relayer A is colluding, all of this risk is only borne by those user applications accepting messages from oracle A and relayer A. All user applications using relayer BZ, running their own relayer, or using oracle BZ remain completely unaffected. This is a massive transformation in terms of risk model from the previously described middle chain systems. Sixthly, unified liquidity bridge. Bridges today compete to attract liquidity providers, LPs, fragmenting liquidity between bridges and their individual pairwise pools. Instead of having one pool that provides liquidity for an asset to all connected chains, LPs must choose a single pool that connects to one chain. Layerzero enables the holy grail of bridging, unified liquidity across all chains with guaranteed finality on the source chain. This means when a user transfers an asset from chain A to chain B, the user is guaranteed the asset on chain B, and the LP providers receive fees from all incoming transactions to chain B regardless of the source chain. Finally, lending and borrowing. Currently, if a user has money on chain A but wants to farm on chain B, the user would have to collateralize on chain A, borrow, bridge, fee, swap, fee, farm on the destination chain, swap back, fee, bridge back, fee, repay the loan, and uncollateralize. With Layerzero you can collateralize on chain A, borrow on the destination chain, farm, repay, and the collateral is unlocked, skipping the 4 bridging and swapping fees. PreCrime in Layerzero. Introducing PreCrime, the ability for a relayer to stop a hack before it happens. PreCrime is achieved by forking a destination blockchain before delivery of a message and running the transaction locally. After running the transaction, PreCrime can check the state of the blockchain in relation to the other connected blockchains to verify no malicious action occurred. These malicious states are defined by the user application, UA, and enforced by the relayer. PreCrime provides UAs an additional level of security beyond their audits and bug bounties. Relayers can now run a UA-defined set of assertions on a locally forked blockchain to verify that every message being delivered will never result in a compromised state. If the assertions ever fail, the relayer will not deliver the message, preventing the attack and saving the UA from disaster. PreCrime is just one of many steps Layerzero is taking to ensure the security of the omnichain future. Currently, the Layerzero Labs relayer is running a light version of PreCrime that will be hardened in the coming months. In the future, PreCrime will be available to all user applications willing to opt in to help protect their project. Let's meet the team behind Layerzero. Layerzero Labs co-founders from left to right, Caleb Bannister, Ryan Zarek, and Brian Pellegrino. Brian is a 2-time founder in online fantasy sports and predictive AI, and has a past life as a poker champion, another field where game theoretic assumptions reign. Ryan was a founding CTO with Brian on the sports startup, and has been a 3-time co-founder with Caleb in both AI and blockchain-related startups. Layerzero investors. Layerzero raised $135 million in a Series A round co-led by A16Z, FTX Ventures and Sequoia Capital, and with participation from Binance Labs, Coinbase Ventures, Animoca Brands, Defiance Capital, Spartan, Multicoin Capital, Delphi Digital, Echelon Capital, Sino Global Capital, Genblock Capital, Hypersphere, Avalanche, Tiger Global, Uniswap Labs, Robot Ventures, Protocol, Polygon, Vault Capital, Gemini, CoinFund, Phantom, Zokio and more. Thanks for watching. And head to our website now for more details about Layerzero project.